All right, guys, today we're moving on to 4.4b, multiplying special case binomials. And so this is going to be really familiar to you since, especially over the last couple of days, we've been working on multiplying just regular binomials together. Here, you're just going to really just see some special cases here that we're going to be looking at. And I want to start with number one here. And a lot of these are similar. So again, it's not going to be too difficult to you. I got to get my pen darker than what it is right now. It's just not working. All right. So I want to just bring back some familiarity here. What if I said, for example, 2 squared? If I said 2 squared, again, what I'm really saying here is I need to take this base and I need to replicate it 2 times or copy it 2 times, and I need to have multiplication in between. Okay, so I'm really saying 2 times 2. Okay, so that of course becomes 4. So 2 squared is the same thing as 4. When you have a binomial that is being squared, I want you to recognize that that is also saying the same thing. And so what a lot of students do when they get something like this is they think, well, this is the same thing as just taking negative 5v squared and taking negative 6 squared. And they kind of do that math and come up with an answer, but that's not truly how this is really to be done. Okay, this is not correct. And so what you really have when you have this situation like this, I could have just as easily said parenthesis 2 parenthesis squared equals, which means the same thing, that I need to repeat that base twice. Okay, so what we're really saying when we're saying this right here is we're saying that's the same thing as negative 5v minus 6 times negative 5v minus 6. Okay, which will not be the same as what this over here is. Okay, so I really wanted to emphasize that point, that this is basically this exponent is saying I need to repeat this base twice and do multiplication in between it. Okay, and so even though maybe there's not a raised dot there, we know that is multiplication when you have 2 binomials right beside one another. So at this point, it becomes exactly like the ones you did yesterday. Again, we're going to use the full method, which is basically just the distributive property. Okay, you're just distributing each one of these terms in the first binomial through the terms in the second binomial. But I want you to notice what happens in this particular instance. Okay, so we have negative 5v times negative 5v. Well, a negative times a negative is positive, so it gives me 25v. And remember, this is v to the first times v to the first, so that's going to give me v squared. Okay, now notice what happens here. I've got negative 5v times negative 6. So a negative times a negative is going to be positive. 5 times 6 is 30, and the v is kind of going to come along for the ride. Now watch what happens. When I do my inner terms, remember we're doing full here. When I do my inner terms, I've got negative 6 times negative 5v. Negative times a negative is positive again. 6 times 5 is 30, and the v again just kind of comes along for the ride. So you get a repetitive term here. Okay, you get a repetitive term, and so that's pretty important, because that's going to happen every single time that you're working with this particular type of binomial. Okay, so the next thing that happens is you've got a negative 6 times a negative 6, which is going to be a positive, and 6 times 6 is 36. Okay, so our final answer we're going to end up with again is we need to collect some like terms. So here are our like terms. They just happen to be all kind of collected in the middle. And so when we finish this one out, we're going to have 25v squared plus 60v plus 36. Now, I want you to think about what really happened here. If I were to look at this as a minus b squared, I'm going to have a minus b times a minus b, right? And let's just go down this path for a minute. So I'm going to end up with a squared for my first terms. I'm going to end up with b squared as my last terms. And in this particular instance, notice what happens. If I did a times negative b, I would end up with a negative ab. And this negative b times a is negative ab again. So really what I end up with is a squared minus 2ab's, because I've got two of them, right? Here's my like terms, plus b squared. And so you're going to see anytime you have something like this right here, you are going to have this particular situation right here. And so what can happen is you can very quickly begin to see how that I can just take my first terms, square them. I can take my last term and square them. I can take my a times my b and multiply that times a negative 2, and all of a sudden I've got the answer, okay? So it's a little bit of a shortcut that can get you all the way to this answer without having to go through the entire process, okay? Again, if you need to go through the entire process like we just did, then that's perfectly fine. And every situation is going to be a little bit different. You notice on this one I had a negative and a negative, okay? So that created a little bit different situation. This was not negative, it was actually positive, okay? So every situation is going to be a little bit different. But again, you can kind of see how that this could be used to help you try to figure out some situations, okay? So let's look at one more example of that real quick. If we had a plus b squared, again, I'm going to have, that's the same thing as a plus b times a plus b, which is going to give me a squared, right? And then a times b, which is going to be positive, and I'm going to have another positive a times b, and then last but not least, I'm going to have b squared. So you can see how in this situation, I have a squared plus 2ab plus b squared. So a little bit different than what we got before, but basically look at the difference. Here you have a positive, there you have a positive. Here you have a negative, there you have a negative. So again, you can kind of see how this really begins to create kind of a shortcut, okay? And that's the reason that these are, in fact, special case binomials, all right? So now let's look at the other example. So that was number one. And again, we did a lot of notes there, but again, you could walk through that same entire process and see what happens. But I just want you to see that kind of those middle terms are the only thing that really changes. Really, you're just squaring the first terms and the last terms. Now let's look at this one, which is really one of my favorites, okay? And so let's go ahead and look at number 11. And so again, we're just given plain old binomials here, and we're told to simplify this. So let's look at what happens here. And I want you to notice, just take a look at your terms here. I've got a negative 6a. Here I have a negative 6a. Here I have a 6. And here I have a 6. The only difference in these two binomial terms are these signs right here, okay? One has a negative and one has a positive. So these binomial terms are exactly the same, except for one has a negative and one has a positive. And I want you to see what happens with this particular situation, okay? This creates something really special that I know is going to be kind of exciting, I hope, for you. So negative 6a times negative 6a. Let's look at what happens. Negative 6 times negative 6 is 36. A times a is just a squared. And now I'm going to take my negative 6a times a positive 6. Negative times a positive is negative. 6 times 6 is 36. And it's just going to have an a right there. That's going to come along for the ride. Now notice what happens when I multiply my inner terms. I have a negative times a negative, which is a positive. 6 times 6 is 36. And the a just kind of comes along for the ride. And last but certainly not least, I have negative 6 times a positive 6. So a negative times a positive is negative. 6 times 6 is 36. So look at what happens here. Again, we always kind of look toward the middle, because the middle is where our like terms are. And indeed, right there is our like terms. But notice what happens with these like terms. Negative 36a plus 36a. What happens with that? Well, if I had $36 and I went and spent my $36, which is the same thing as negatively taking away my dollars, and how many dollars do I have left? Well, if you said it canceled, you're exactly correct. It's all gone. So the only thing left, you notice my middle terms completely go away, and the only thing left is, sorry, I should have made that black, and I'll erase that right now. The only thing left is 36a squared minus 36. Now, that had to be some kind of fluke, right? There's no way that this would work every single time. Well, let's take a look at number 12 real quick just to prove the point, okay? So 4 times 4 would be 16n squared. Okay, I'm just kind of doing this fast, but to give you the idea, 4n times 4n is 16n squared. 4n times negative 8 is negative 32n. 8 times 4n here is positive 32n. And 8 times negative 8 is negative 64. Lo and behold, look what happened again. Those center terms are going to go away, and the only thing I'm going to be left with is 16n squared minus 64. So again, you're kind of noticing here when I have exactly the same terms, the only difference, think about it, difference is the signs. The signs are different. When the only difference is the signs, then I'm actually going to get rid of my middle terms altogether. So really, I don't have to do full-blown full here because the outer and the inner are going to go away. They're going to cancel anyway. So I can do FLA, okay? I can do FLA on these particular examples like this right here because I'm not going to need to do everything. And again, it's all about time. ACT is 60 minutes, 60 questions. So anything we can do to try to save time is going to help us. So for example, with number 14, I'm almost doing all of them here, but it's okay. I don't even need to do, look, I've got the same terms, exactly the same terms. The only difference is the signs. So as soon as I see that, all I have to do is I have to do FLA. Well, my first terms are negative 3 and negative 3, which is positive 9. And I have 2k times 2k, so that's going to be 4k squared. And looky there, I'm already done. You can probably hear my phone ringing. That's okay. It happens. So I'm sure they'll get a hold of me again if they need to. But you can see here that very quickly I was able to get to this answer without having to go through the full-blown process, okay? So let me give you just a little bit of a model to work with here. If I've got a plus b times a minus b, okay? Again, same terms, only difference is the sign. If I've got that situation right there, all I have to do is a squared minus b squared. And I promise you, this is going to become really, really important when we get ready to start factoring, because what's going to happen is they're actually going to give it to you in this format, and you're going to have to take it back to this format, okay? And that's why we're spending the time right now helping you to kind of see the relationships, to see how all this stuff works together, so that when you see it later on, that you'll understand exactly what's going on, okay? So again, if you need any help, make sure to reach out to me or Miss Wheeler. There's 20, I think, on this sheet. So we did almost 5 of them. So you've got about 15 left to do. But these, I think, are going to be pretty easy for you to be able to accomplish. All right, if you need help, just make sure and ask us. Thanks.